بسم الله الرحمن الرحيم. We are in this topic, which is the derivatives of the logarithmic functions. In the last two parts, we discussed the differentiation of logarithmic functions, and we gave different type of examples. Just for reminding, we said that the derivative of logarithmic function is equal to f prime of x divided by f of x multiplied by ln of the base b. That was the rule for the derivatives of logarithmic functions. And we gave some properties of the logarithm, where we use these properties to simplify some problems where the function is very complicated. When it is not easy to find the derivative in the direct rules, we have to simplify it by using the logarithmic differentiation. And this will be just small reminding about that one. Let's find y prime. Number one, y equal to, say that I have square root of square minus 1 multiplied by sine to power 3 divided by then x multiplied by to power 5. And we need to find the derivative of this function. We can apply the quotient and product and chain rule to find the derivative of this one, but it will be complicated a little bit. It will not be easy. So the easier way, or another way to find the derivative, that we will take ln for the both sides of this equation and simplify it, as we did in the last part. So let's take ln. I will have ln of y equal to ln of x squared minus 1 to the power 1/2 multiplied by sine to the power 3 of x divided by ln of x multiplied by x squared minus 4 to the power 5. Now let's simplify. This will give me ln of y equal to, it will be 1/2 ln of x squared minus 1 plus, for the third one, for the second one, will be 3 ln sine x. We said that for the properties, this power written down minus ln of x minus, because it is in the denominator. Anything in the denominator in the division part, second part will be negative. So if it is division or divided by, then by the properties it is minus ln. So the denominator will be minus 5 ln of x squared minus 4. So this is the right hand side after we use the properties of logarithm. Now we are going to differentiate. Now I can differentiate. Don't forget, we have to differentiate the left hand side and right hand side. For the left hand side, I will have y prime divided by y equal to 1/2 derivative of ln of x squared minus 1 using the rule. The function is down in the denominator and the derivative is up, so it is 2x divided by x squared minus 1. Second one, plus 3 multiplied by, the function is sine, the derivative is cosine x. Third one, minus. The function is len of x. Because I have len of x, so the function is len of x. Derivative of this function is 1 over x. Minus 5 multiplied by derivative of len of x squared minus 4. The function is down and the derivative is up. So the derivative now y prime is equal to y multiplied by, cancel this with this one, I will have x divided by x squared minus 1 plus 3 cosine over sine, it's cotangent, minus 1 over x multiplied by len x minus 10x divided by x squared minus 4. And this is the derivative of the given function. So in each time you have a very complicated function with product and division and power, then take len to make it easier, then you can differentiate. So take len, simplify it and differentiate. Let me take another example now. Number 2. This would be a different type of examples. X to power x. The power rule, we said that the derivative of x to power n or r is equal to n multiplied by x to power n minus 1. This is if the power is a real number. But if it is not a real number, then we can't apply this one. This is if n equal to real number. But if it is not a real number, we can't apply it. I can't say the derivative is x multiplied by x to power x minus 1, because at the end I will have x to power x. So it is like we did nothing. Some remark for this type of function. In each time f y equal to f of x to power g of x, which means if I have a function to power another function, take them, then differentiate. So for this function now, I will take len. Just to make it easier to differentiate. I will have len of y equal to len of x to power x. And this is power. So we can write it down. So I'll have len of y equal to x multiplied by len of x. Now differentiate. This is product rule by product rule, which is f prime g plus g prime f. The right hand side is multiplication of two functions. So to find the derivative, we will apply the product rule. Now the derivative for this one, left hand side will give me y prime divided by y is equal to, by the product rule, it is 1 multiplied by len of x plus derivative of the second function, which is 1 over x multiplied by x. So y prime is equal to y multiplied by len x plus 1, or it is just because y is x to power x, very small function, I can write it. It is len x plus 1. So this is the derivative. It is x to power x multiplied by len x plus 1. Take another example now. Number 3. Y equal to sine of x to power x. Again, I have a function to power function. So since I have a function to power function, we'll take ln. So it is ln of y equal to ln of sine x to power x. By the properties, this will be ln of y equal, the power is going down, so it is x multiplied by ln of sine x. Now differentiate. I will have y prime divided by y equal to, by the product rule again, this is the product rule. I will have 1 multiplied by ln of sine x plus derivative of ln sine is, the function is down and the derivative is up, multiplied by x, because it's f prime g plus g prime f. So the derivative y prime will be y multiplied by ln of sine x plus x multiplied by cotangent. Or I just simply can write it as sine x to power x, because y is sine x to power x multiplied by ln of plus x multiplied by cotangent of x. This is the derivative of the given function. Again, if you are given a function to power another function, just take ln to simplify it. One more example. Number 4. Suppose that you are given y equal to x squared minus 3x plus 5 minus x plus 1 to power, let's say this time, tangent of 2x. X squared minus 3x plus 5 minus x plus 1 all to power tangent 2x. For this example, since I have negative sign between the two terms, I cannot take ln directly. In this one, I will not be able to take ln to the left-hand side and right-hand side, then differentiate. This is the problem. We have either multiplication or division so that we can apply the properties. But if I have negative or positive, plus or minus between the terms, I cannot take ln to the both sides. But notice one thing here. I have y, I can write this as y1 minus y2. I will take each term as separate function. So it is y1 minus y2. Because in this form, I will have y prime will be y1 prime minus y2 prime, where y1 is equal to x squared minus 3x plus 5. For this one, it is very easy to find the derivative. If we differentiate, I will have y1 prime will be 2x minus 3. So this is done. So the derivative of the first part is done. It is very easy. Now let's see the second one. y2 is equal to x plus 1 to power tangent to x. But this of the form a function to power another function. So we have to take len to find the derivative. Take len. So we'll have len of y2 will be, this is power, I can write it down directly as tangent of 2x multiplied by len x plus 1. I just ignore one step, that is just a power, I can write it down, and it will be tangent 2x multiplied by len x plus 1. Now differentiate. The left hand side will give me y2 prime divided by y2 equal. The left hand side, we have to apply the product rule. So I will have derivative of the tangent 2x is secant square and the derivative of the angle is 2. So it is 2 multiplied by. This is the derivative of the tangent 2x, it is 2 secant square 2x multiplied by len of x plus 1. Product rule, it is f prime g. What we found now is only f prime. Still I have another one, another part, which is g prime multiplied by f. Now the derivative of g, which is the second function, is this one, plus x plus 1, and the derivative is 1. So it is 1 over x plus 1 multiplied by the first function, which is tangent to x. Now y2 prime will be y2 multiplied by 2 secant square of 2x multiplied by len x plus 1 plus tangent 2x divided by x plus 1. So this is the derivative of the second function. Now combining all of these, I will have y prime, the general function, will be y1 prime plus or minus y2 prime. y1 prime, we found it up as 2x minus 3. That will be 2x minus 3. This is the first derivative minus y2. It was x plus 1 to power tangent multiplied by all of these inside the bracket 2 secant square of 2x len x plus 1 plus the tangent divided by x plus 1. So this is the derivative of the given function. Or what we did, we just separated the two terms and we found the derivative for each one of them, and then we write them back again. So y prime is y1 prime minus y2 prime. Just rewrite the derivatives in this equation, and that's it. This will give you the derivative.